Okay, let's get ready for this quiz. So we're going over the review today. Number one, the table shows the average daily energy requirements for male children and adolescents. Use a calculator to find the line of best fit. Okay, now we know how to find the equation of a line. We've done it a lot before. This is a scatter plot. We're just going to use the first and the last point. So first thing we need to do is find the slope, y minus y over x minus x. And then we're going to go y minus y equals m times x minus x. Okay, so first let's find the slope. So we need to use the y's first. And maybe what I'll do is I'll write this actually as an ordered pair. 1,100, and 17, 3,000. Okay, so y's go on top, x's go on the bottom. So we're going to have 1,100 minus 3,000 on the top. And on the bottom, we're going to have 1 minus 17. Okay, now when we do this, I'm going to write it up above. This is going to be negative 1,900 over negative 16. And that's going to be... Now it's going to give it to me, it might give it to you as a fraction. I want to change it to a decimal this time for these scatter plots. And this is going to be 118.75. 118.75. So let's come down here and put it in. Y minus, now I'm going to choose the first point, the first xy. Okay, so I'm going to have y minus 1,100 equals my slope, which was 118.75 times x minus 1. Distribute the right side, so this is just distributive property. 118.75x, 118.75 times negative 1 is going to be negative 118.75. And then add the 1,100 over, plus 1,100, and I'm going to have y equals 118.75x plus 981.25. I'll write this over here nice and big. Y equals 118.75x plus 981.25. Okay, so that's the line of best fit. Letter B, use your linear model to predict how many calories a 19-year-old needs per day. Okay, so 19, that's our x. All we have to use is the equation that we just wrote in the top, and we need to sub 19 in for x. So if I put in 118.75 times 19 plus 981.25, it's going to give me 3,237.5. Okay, and so I ask, does that make sense? Does this fit with what we have up in this table? Let's just look. If I looked for a 19-year-old would be up here. Would that be about 3,200? Yeah, it sure looks like it would. So we're in the right ballpark, and we could feel pretty confident about that of 3,275. Letter C, use your linear model to predict the age of a male who needs 2,300 calories per day. Okay, so this one's just going to be a little bit different. This time the 2,300, that's the calories, that's going to go in for Y. So we're going to put in 2,300 is equal to 118.75 plus 981.25. Okay, so let's just solve this. Subtract the 981.25 over 2,300 minus 981.25, and that's going to be 1,318.75. And that's equal to 118.75. Whoops, I forgot the x in there. So the last thing, I just need to take that and divide by 118.75. And that's going to be approximately 11 years old. Okay, so let's go back and cover this again. For letter B, well, for letter A, first thing, find the slope, y minus y over x minus x. Then put that into point-slope form, y minus y equals m times x minus x. And that's letter A, and we get our equation. For letter B, we know it's a 19-year-old person, so we need to put in 19 in for x in that equation and just use your calculator. Letter C, when we know it's 2,300 calories, that's our y variable, so put in 2,300, and after I've done that, you're just going to subtract the 981 and then divide by the 118. Okay? Pretty easy. Letter D, do you think this model also applies to adult males? Explain. Well, no, it's not going to. If you put in a number like, let's pick a number for an adult male like 60, okay? If you put 60 in for X, you're going to get a huge number of calories that no adult male is going to need, okay? So does this work for adult males? No, because eventually men stop growing, stop getting bigger, stop needing that many calories, and so no, it is not going to work for adults. Number 2, you want to buy some CDs that cost $10 each and some DVDs that cost $15 each. You have $45 to spend. Letter A, write an inequality to represent the situation. Okay, so first let's write an equation, okay? So $10 each means multiply, right? So that is 10 times C, and we're also going to buy some DVDs that cost $15 each. So that's going to be 15 times D for DVD, and we have $45. Okay, now, if I read this again, it says X is the number of CDs. So maybe what I should do is come up and write an X instead of a C, and Y is the number of DVDs. Okay? The last thing that we need to finish this up for letter A is to write this as an inequality. Okay? So here, that means I don't have an equal sign. I need to change that equal sign somehow. So on the left side, this 10x plus 15y, that right there is how much we're spending. $45 is how much we have. And so what we spend has to be less than or equal to what we have. So our inequality is going to be 10x plus 15y is less than or equal to 45. Let's look at B, graph the inequality. Now, I am going to make this just as easy as I possibly could. So the y value is DVDs. CDs were the x value. Okay, so I've got a question. If we've got $45 and we only buy DVDs for $15 each, how many could we buy? What's 45 divided by 15? That's going to be 3. So if we only bought DVDs, we could buy 3 of them. Let's do the same thing with CDs. If we only buy CDs for $10 each, how many could we buy? Well, that would be 4. We could buy 4 CDs. Okay, so if it's only DVDs, it's 3. If it's only CDs, it's 4. Well, all I'm going to do is draw a line in between them. And if we look at our inequality, it is going to be a solid line because it's less than or equal to. And since it's less than or equal to, we have to shade everything below that line. And that's our graph. Okay? Letter C, I'm sorry. Why did the graph in B only include quadrant 1? Well, I only included quadrant 1 there. And let me draw this. If I just made this a little bit wider, now we would see what a kind of a normal looking coordinate plane. And this area up here, this is quadrant 1. Quadrant 2 is over here, quadrant 3 is down here, and quadrant 4 is down there. Okay, so that's what it's talking about, only quadrant 1. So why is it only in quadrant 1? Well, if we went down any further, that would be negative DVDs. We can't buy negative DVDs. If we went back to the left any further, that would be negative CDs, right? Like this number right here is 0. And we can't buy negative DVDs or CDs, so it's just going to be in quadrant 1, okay, because we have to buy a positive number. Letter D, can we buy 3 CDs and 2 DVDs? Well, if our graph was really good, we could look at it and get that answer from there. I'm not super confident in the accuracy of the graph, so here's what I'm going to do. I know a CD is $10, so I just want to know what's 10 times 3, and 2 times a DVD is $15. And is that less than or equal to 45? Well, let's see. That's going to be $30 for the CDs, $30 for the DVDs, 30 plus 30 is going to be $60, and we only have $45 to spend, so no, we cannot do that. All right, let's look at the next one. Number 3. Okay, this one is just mind-blowingly easy. Write an absolute value inequality. So I know I'm going to have a y and an absolute value of x, okay, for which the boundary is dashed and the shaded region is above the boundary. Okay, so I need my inequality sign. How do I make it, first of all, how do I make it shade above the boundary? Well, above means greater than, so I'm going to put the greater than sign in there. And how do I make it dashed? Well, if I put the equal sign underneath there, that's going to be equal to, that's going to be a solid line. I don't want solid, I want dashed, so I'm just going to keep it as greater than. So you can do anything else you want, you just have to have the y, the greater than, and the absolute value of x. If you want to add a +7, a -6, if you want to multiply it by 3, that's fine. Just make sure you have these basic components, and you can simply do that. That's an absolute value inequality, absolute value inequality sign, and the boundary is dashed because there's no equal sign down there. That equal sign doesn't exist. And it's above because it's greater than. Okay, so we've got that. Let's look at number 4. The graph at the right relates the number of hours you spend sleeping to the number of hours you spend on the computer each week. Letter A, describe the domain for the situation. Domain is your x values. What do we have down here on our graph? Well, we started, the smallest that we get is 0, and the biggest we get is 48. Okay, so we can just kind of write this in interval notation like that, saying that it goes from 0 to 48. 0 is the smallest, our x gets, 48 is the biggest. Okay, write an inequality for this graph. Well, see, here's what we're doing. It looks like it goes to 48 on both sides, so if we just add the amount of time that we spend sleeping and the amount of time we spend on video games, that has to be less than or equal to 48, okay? So we've just got that x and y, because that's the two things we're adding, and the 48 comes from there because it's 48 on both sides, both the x and the y, so we don't need to make it any more complicated. We can just use 48. And less than, because it's shaded below, and equal because it is solid. So that's the inequality. X plus y is less than or equal to 48. Letter C, what's the least amount of time you can spend sleeping? Well, let's say that this bottom was sleeping and the y was computers. Okay, what's the least amount of time you can spend sleeping? Well, looking back here, the smallest our x ever is 0. Does that make sense? That's the least amount of time you can spend sleeping during the weekend. Not a good idea to sleep 0 hours, but it is possible. The next one, what's the most amount of time you can spend on the computer? So the computer is the y-axis right here, and it looks like it goes up to 48. So the most you can spend is 48. So the most time you can spend on a computer in a weekend is 48 hours. Again, not a good idea, but you can do it. All right, so letter D, why does this graph go only to 48 on both the x and the y-axis? We're only going up to 48 both ways. Well, why is that? The answer should be obvious. There's only 48 hours in a weekend. Okay, only 48 hours, that's the most that we can have. Okay, these, describe each transformation. So, out here, that +3 at the end means it goes up 3. Okay, number 7, the next one, this -7, it's with the x, so the x is sliding left and right. So a -7 sure would make a lot of sense that it would go left 7, but x's are opposite, right? X's are opposite, so instead of going left 7, this is actually going to go right 7. write 7. And it's like you're adding 7 to the x. Okay, so let's, this next one. So what is this going to do? Remember, x's are opposite, so these are left and right. Opposite of minus 4, that's plus 4. This is going to actually go right 4. And then this minus 5 is up and down, and that's going to go down 5. Okay, so the number at the end, that's up and down, and that's going to tell you the truth. Plus 3 means up 3, minus 5 means down 5. In with the x, though, those are backwards. The x's are liars, okay? X's are liars. Minus 7 is actually going to go right 7, like a plus 7, and the minus 4 is actually going to be like a plus 4 going right 4. Okay, let's do this last part. Last section for this review. Okay, so what do I see? I see that this is a v, and I remember that a v is absolute value of x. And let's see, right here is the kind of the vertex of that graph, and we know that it started at 0, 0, so it looks like we just slid it down 3. So I'm just going to put a minus 3 here, and that's the equation of that graph. Okay, let's look at the next one. I see this shape there. It's kind of got 3 parts on it. I recognize that. That's y equals x to the 3rd. Now, what did we do? Well, the vertex is right here, and I know it started at 0, 0 right there, so it looks like I just slid it down 1. So how do I make this go down 1? I'm just going to go minus 1 like that. Okay, next one. That shape, that's like a half of a graph. So the exponent's kind of like a half, which is a square root. This is square root of x. Okay, now this point right here where we started, that normally is back at 0, 0. So it looks like I went left 2. So remember, if I'm going left and right, that's with my x. So I've got to put this number, my 2, by my x, right inside with that. How do I make it go left 2? Well, that's at negative 2. Sure would make sense that I'm just going minus 2. But remember, x's are liars. Instead of going left 2, instead of subtracting 2, I have to add 2 to get there. And that's my answer. Okay? So I know this was a lot. I know I went fast. If you need any help, if you were confused by this, go back and just watch it again. All right? I know you got it. Good luck.